I'm going to present about InnoDB ClusterSet, which is a disaster recovery for InnoDB Cluster. My name is Leonardo. I'm a senior support engineer at Percona. I've been working with MySQL and Mongo there for the last 3 years, and with other database technologies for the past 8 years. And here's a bit about the agenda for today. We're going to talk about the concept of InnoDB ClusterSet. And to do that, we will need to start with InnoDB Cluster and work our way up from there. Then we will talk about some use cases and limitations of InnoDB ClusterSet, some requirements that you need to deploy it. Then we're going to see how it can be deployed, and some basic maintenances, which is controlled switchover and an emergency failover. So the InnoDB ClusterSet is a disaster recovery solution for InnoDB Cluster, coupled with a lot of great MySQL shell automation. So to talk more about ClusterSet, we need to first understand what is the InnoDB cluster, which is complete. The InnoDB cluster is the high availability solution for InnoDB, which is different from the ClusterSet, which is a disaster recovery solution for this HA solution. And the InnoDB cluster is a grouping of the MySQL group replication with MySQL router paired with MySQL shell. So this image is from the documentation that we can use as a reference. So it starts with group replication, 3 instances of databases in a high availability cluster, and then you add MySQL router as a middleware, so your application can connect to the router, and it should route to whatever is the primary instance or the secondary or whichever operation. It becomes transparent for your application, and as you just connect to the MySQL router, and it will take care to get you where you want. And that is all deployed, managed, and monitored with the help of the MySQL shell. So what about the InnoDB ClusterSet? It's a disaster recovery solution for the InnoDB cluster, which is the InnoDB cluster plus regular asynchronous replication, the regular MySQL asynchronous replication. It's not a high availability solution. The high availability is from the InnoDB cluster, and it's an important distinction to make, which we will talk more about as we go on the presentation. And it's the asynchronous InnoDB cluster plus asynchronous replication deployed and managed through MySQL shell. So this is the image you have on the ClusterSet documentation, which is a lot of information to take in. But this is what would be a primary cluster of primary InnoDB cluster. You have the databases, as we saw in the last image, with the MySQL router as a middleware. And then you get asynchronous replication to other secondary databases, and in this case, other secondary InnoDB clusters. And then you have the primary replicating to the secondaries. So when should I use it, and what should I be aware of when using the ClusterSet? It's usually often used as a cross-datacenter InnoDB cluster replication, which comes with all the limitations and all the pros and cons of using MySQL regular asynchronous replication. So, for example, your DR cluster can be used for reading. If you have applications in multiple data centers, you can read locally on your secondary. All writes will need to go to the primary, You can't write directly to the secondaries, but you can use the local DR cluster for reading, for example. It has a very easy switchover and failover. It's completely automated with a single command on MySQL shell, which we will see later in the presentation. And one thing to keep in mind is that failover needs to be triggered manually. So it's not focused on getting high availability and keeping your application up. It's to recover from a disaster, and not often you will prefer a failover. It's often preferred to just bring back your primary cluster up if possible. So the failover decision needs to be done by a system administrator for a DBA, and it needs to be done manually. And there are some things that you need to be aware of when using the cluster set. Otherwise, they might come as a surprise when during a crisis. So it is an asynchronous replication, so it has the limitations of asynchronous replication. So your replica can lag behind. The data won't be the same at the exact point in time. If you lose your primary, you might not have replicated all the transactions to your secondary cluster. So you need to keep that in mind, that doing a failover might occur data loss. So you need to be aware of this when doing a failover. It prioritizes disaster recovery over data consistency. So if your primary cluster is really down, it doesn't matter if it wasn't completely in sync or anything. If you want to use the secondary, you want the secondary to become the primary, it won't check data consistency or anything, but it would just bring it up and allow writes on it. And as I said, manual intervention is necessary for failover, and data loss may occur during failover, which is why it needs to be done manually and not automatically. And data consistency, it's just important to mention it's guaranteed locally in each InnoDB cluster by group replication. Like it comes with the package, but it's not guaranteed between the primary and secondary clusters. And it does not support synchronous replication. When you see MySQL asynchronous replication, there's an option to have a synchronous one, which keeps the primary and secondary in synchrony, but that's not an option for the InnoDB cluster set, at least not yet. And all these limitations. Sorry, go ahead.
Could you please provide some example of problems related to data consistency loss, except the replication, the replication lag?
So when you commit to the primary, it will take some a minimal lag to get the binary log and replicate and apply, and you might the primary might die like a kill-9 or a network failure, or a data center powering off, and the last 1-2 transactions will often not be available. If it's a complete disaster, it won't be available in the secondary. So when you start writing to the secondary, when you bring back the primary, you can't start replicating because some primary keys will conflict, and you will need to reconcile them manually. So that's what I mean by data loss.
But that's only one case, right? I mean,
yes, that's.
This one is obvious, but there is nothing except that.
No, not that I can think of. Yeah, that's the most common because it will occur. So this begs the question: if data consistency is not guaranteed, it's not high availability, so why not use one InnoDB clusters with nodes in multiple data centers? Why use ClusterSet? And the reason is basically performance trade-off. if you want your data synchronously on multiple data centers, the InnoDB cluster needs it needs an acknowledgement for every write from every node, and putting like cross data center communication in the middle of every insert will have a performance impact. Although it's a completely reasonable solution and is one way to get your data completely synchronous through multiple data centers, but you need to be aware it's a trade-off. You gain consistency over multiple data centers, but you lose write performance. As the slower the network, the bigger the overhead for writes. And why not set up InnoDB cluster with the regular asynchronous replication, which we're all familiar with and know by heart for now. And the reason is it's also a completely valid way of doing this, but the InnoDB ClusterSet brings a lot of automation to the solution. So it has its strengths and the ease of managing, of switching over and that kind of thing. So to deploy an InnoDB ClusterSet, there are some requirements before we get started. InnoDB ClusterSet is a new feature that was released on 8.0.27. So you need at least 8.0.27 or higher to be able to use the InnoDB ClusterSet. You need one InnoDB cluster to use as a source, and one or multiple standalone servers to become the replica cluster. Oh, you can't have two InnoDB clusters on multiple data centers and just tell the MySQL shell to administer them as a cluster set. You need to build it through MySQL shell by having one cluster as source and then adding replicas, and it will create the InnoDB cluster on your replica. You need to use MySQL router, and there are some requirements for the InnoDB cluster that you're going to use as a source, which is all members must be 8.0.27. Metadata version must be 2.1 or higher. So this is the metadata that MySQL shell uses for compatibility. So when you have MySQL shell, when you have a MySQL server, for example, version 8.0.26 with metadata for MySQL shell 8.0.26, all MySQL shells from 8.0.26 and up are able to manage and control and do operations on that cluster. So when you upgrade your metadata version for 2.1, it tells that only MySQL shells that are 8.0.27 or higher can manage this cluster. So since 8.0.26, yeah, go ahead.
Is it something you can upgrade easily?
Yes, it's one comment, yeah. It just changes the metadata, which basically says a MySQL shell 8.0.26 can't use it.
Is any restart required?
No restart. It's just, yeah, it seems lazy. Another requirement is the source needs to be in single primary mode. InnoDB clusters can be multiple primaries or single primary, but for InnoDB ClusterSet, it needs to be in single primary mode. Otherwise, it won't work. It won't allow you to create your cluster set. And your source InnoDB cluster can only be part of one cluster set. You can't have one source being part of multiple cluster sets managed by different shells, which would get messy really quickly. So it can only be part of one InnoDB cluster set. And as I said, you can't use the one InnoDB cluster as a replica. It needs to be the source, and then you build the replica through MySQL shell. And the standalone servers that are going to be used to build the replica, they can't be part of an InnoDB cluster, another cluster set, or a replica set deployment. They all need to be 8.0.27 plus, and all members, all standalone servers need to be on the same version. This is also a requirement for the source InnoDB cluster, but you won't be able to build a source InnoDB cluster in the first place with all mismatching versions. But since you're adding standalone servers, you yourself need to guarantee it's the same version for everybody. And you need unique server IDs and server UUIDs between all the nodes that you're going to add, as well as the source InnoDB cluster. And this is obvious, but I thought it was worth mentioning. You need to be able to connect to the primary cluster. So, and you need to go both ways, because if you ever switch over, you need to be able, the new replica will need to be able to connect to the new source, and vice versa. And the standalone servers that you're going to add to create your cluster sets, they need to be online and they need to be healthy. So to deploy InnoDB cluster sets, I started this. We use DB deployer in support for most automations and testing, and it has a command that deploys a group replication. So we're starting from a group replication, then we build an InnoDB cluster, and using the InnoDB cluster, we build the cluster set. So it's just, you can configure them manually or whatever tool you prefer. MySQL Shell also has some great automation for deploying sandboxes. So I deployed a 3-node group replication. So before we use that group replication to build the InnoDB cluster, it needs to do some checks and some maintenances. You need to make sure some parameters are set and metadata is all okay. And that's just one comment, which is configure instance. And you point it to the primary of your group replication. And it's just a prompt that asks, it will tell you all it needs to alter, and will ask if you want it to do the changes for you. And you can just accept, it will do it for you. And to create an InnoDB cluster with a cluster set, it is also just one comment, which is create cluster. And you give it a name. In this case, I called it gr01, which is the one we will use as a source. MySQL shell connects to that group replication. It will mention that it detected a group replication, and will ask if you want to build your InnoDB cluster based on this replication group, and we'll just do the metadata changes that it needs to create this InnoDB cluster. Once it's created, there's a status comment that will tell you how its health, which members are online, what are the member roles, if the nodes are read-write, and how's the status of the cluster, if it's accessible. And it will also tell you the topology. In this case, I left it as the default multi-primary, which doesn't work for cluster set, but just to show the kinds of checks that are done when you try to create a InnoDB cluster set. So it's also just one comment based on your previously created InnoDB cluster. You just give it a name. I put the name cluster set there, which might be a bit confusing in hindsight, but I named it cluster set. And the first thing it does, it mentions it's going to create your cluster set based on our cluster gr01. And the first thing it does, it validates the cluster for compliance. In this case, as we left as multi-primary mode, and that doesn't work with cluster sets, it will just tell you that it's an unsupported topology and that you need to change it. There are some checks that will just give you the command that you need to run to fix it. But in this case, it's just a switch to single primary mode. And it will choose one node to become the primary, and the others will take on the role of secondaries. And then you can use your cluster to create a cluster set. So it validates the cluster, and it does some metadata changes, and you have a cluster set with only one cluster, which is your source. And you can check the status of your cluster set. It will tell you the clusters that are part of your cluster set. It can be, you can have multiple replicas. It doesn't need to be only 2 or 3. It will tell you who is the primary for each clusters and which cluster is the primary cluster. In this case, since we only have GR01, that guy is the primary. And it will tell you if the cluster is available and healthy. So just as a reference, so right now, from that first cluster set image we had in the beginning, currently we only have one primary InnoDB cluster, which in this case, for example, is the one in the middle. That would be our cluster set for now. It only has one InnoDB cluster in it, and we need to add this servers that will build the replica cluster. So you also need to do the configure instance. That it will check if you have all the variables set, to become to add this node to your replica, and then it's just one comment as well. You use your cluster set, and you create replica cluster, and you put the name of your new replica, the address of the single instance that you're gonna use. It will automatically clone. It will ask you how you want to clone your primary. In this case, the clone is the default, and it is one of the best performing ways of cloning data. So if you just accept, it will do all it needs to do. It will change the replication source of your single instance to replicate from the primary of your InnoDB cluster. It will replicate all transactions, and it will create your secondary cluster for your cluster set. So if we do the status command again, it will have 2 clusters in it now. The secondary cluster, the cluster GR02, will only have a node for now. We'll add more, but you have GR01 as the primary. It will tell you the primary cluster on the status, and which is the instance, and it's in healthy status because it's all good and can be used. So you just basically add the other instances to the secondary cluster, and it will clone. You can clone from. It will clone from the primary of your secondary cluster. So it doesn't need to always copy from the primary data center. Since you created a cluster set as a replica, it can use that to build your secondary cluster. Now our status, and there's an extended version which shows the health of every single node. But now our status will show 2 different clusters, GR01, and it will show you the topology with all the nodes, the rows of each node, and it will and you have the secondary cluster, which will be the cluster role as replica, and the applier status. It will tell you if it's lagging behind, if it applied everything it needed to apply, and how the replication is working, and the topology of every single node in there. So the deployment is as simple as that. Those were a lot of outputs, but in reality, they're just 3 comments, which is create cluster set based on your primary cluster, and then you add each node you create the secondary replica cluster based on one of your single instances, and then you add each node, and we will clone everything and apply all transactions. It needs to be up and healthy. And the switchover is really simple as well. It's one comment set to primary cluster, and you choose which cluster you want to become the new primary. When all nodes are up and running, it will check the status of every cluster, and will do all it needs, changing the replication source from one to another. On the newly released version 8.0.29, it also added some parameters to configure some timeouts for your switchover. So for example, if you have like a large transaction happening on the primary cluster, it will wait for it to finish before doing the switchover, and there can't be any writes happening on the primary at the time. So if you have a large transaction, you can actually configure a timeout and what the switchover will do in case of timeout, if it will kill the transaction, if it will switch over anyway, or like whatever behavior you want it to have. But it's basically one comment. It will change all the replication sources from the secondaries. It will change, it will synchronize, pre-synchronize secondaries, make sure everything is okay. And at the end, you get your cluster promoted, and you have the new primary instance there that you can write to. And it's as simple as that. It's one comment, and it will do all the checks it needs. It will reconfigure all the synchronous replication both ways, and you're good to go. You have a new primary. The failover, as I mentioned, is a bit more tricky. But just to demonstrate, I just killed every node in the primary, which at the time was gr2. And you couldn't, when you ran a status command, you'd have this loss of connection. It's not available. You need to connect to one of the surviving clusters, and these reset the variable. So we were using this variable myClusterSet for all the operations. You need to reset it to use the surviving node for all the comments. And when we do a status, it will warn you that replication from primary cluster is not in expected state. It will show the cluster role as replica. It will show the replication status as error because it can't connect to the primary. The replication is broken and failed. And the other cluster, the MySQL shell, since the cluster is down, the node is down, the cluster is down, it can connect to any member from that cluster, and which was the primary. In that case, gr02 was the primary, so MySQL shell just complains it can't connect to any online member and has a status as unknown and unreachable. So, and the InoDB ClusterSet is unavailable because if you can't write and you need to do a failover manually, the cluster is in unusable state. So the end of this status comment will tell the general health of the cluster set in itself, which will be unavailable and not reachable. and you have one comment that you can force a primary cluster, and you put which cluster you want to take on the role as primary. It does some verifications and mentions that none of the instance of the primary cluster could be reached. And it will promote whichever node from the target cluster has the most recent GTAD set. And it does warn you that since the cluster was, the old primary was invalidated, transactions that were not replicated will be lost since you're forcing a failover. It also does mention that you should fence all traffics from the MySQL router to the old node, just in case it becomes online and accepts any writes, or in case the issue was some network connection that wasn't working and then becomes available. That way it warns you that you should avoid split brain. Sorry. To avoid any split brain, you shouldn't connect anything to the cluster that was down when it's brought up. So is that it for the failover? As I said, it's not so simple. You need to make sure there is a lot of manual work in there. So you need to make sure no one is going to connect to the old primary when it becomes up, so you don't have any writes or split brains. You will need to check the replication status. So for example, if it has more data than your new primary, you won't be able to create a replication again. You won't be able to add it because it will have conflicting data. And you manually need to decide what you're going to do with it. If you're going to discard that data, if you're going to reclone from zero, if you're going to try and query the differences and manually fix what wasn't replicated at the time your failover. And only then, after you do all of those, if you find that node is in a usable state, the old primary was in a usable state, you can rejoin it to the cluster set and it will configure your replication back again and make sure that's working. So do you have any questions? There was, yeah, please.
My question's kind of a two-part. It's on the cloning when we're setting up that secondary cluster in the DR site.
Yeah.
What is the clone doing under the covers? Is that like a backup restore?
Yes, it's the MySQL shell has a plugin, a clone plugin that was released on 8.0 something that does basically a backup and it clones data. It was first only available to create replicas, but since ClusterSet was released, you can use it to create a replica set, ClusterSet as well. My colleague Vinicius, he did a blog post on Percona, which when he compared the performance of the clone plugin and like extra backup and like code backups and MySQL dump and all my dumper, I think he compared those 5 solutions for performance, and clone was, I think, the best performing one, or one of the best performing ones at least, which I recommend taking a look.
And then the second piece is, since we are going across data centers, is there a way to avoid the clone and maybe set up the replica from a backup and have it be able to pick up based on the GTID position?
Yes. So I didn't test that to see how much it allowed you freedom to do this. The first one. Let me.
Yeah, it looks like it's available here.
Yeah.
Second line from the.
Yes. Yes. You can do incremental recovery if you copy the data there, and you do incremental recovery, and you have the binary logs from that point forward. It will just use what is there and apply the difference. I didn't test to see how well or how easy that worked, But at least when you're adding the other nodes, it clones locally, which is, yeah, you avoid it there.
Thank you.
You're welcome. Any other questions? Yeah.
So the cross data center replication, right? So
Yes.
that's from one node to the other node. So if that node goes down, the other source, like from the source, it's not going to get the data. So
Yeah, MySQL shell automatically manages that. So if it replicates from primary source to primary secondary, if your primary secondary crashes, it will automatically promote another primary and redo all the necessary configurations and keep it up. And that's automatic, so that's transparent to you. So if the primary changes on the source cluster as well, it will repoint all the replication. So I think 8020 something configures has an automatic replication failover or something. I don't remember the parameter, but that's something that existed for.
it's all automated.
Yeah, all automated. You don't need manual intervention because it just changes which node it has all the information it needs, and you don't lose any data.
That step of change master, you press the list of servers, and then there is an issue. MySQL automatically does the failover.
Yes, that's for regular replication. For this, it's automated. For the cluster set, it's automated. You don't need.
That's using MySQL failover utility or?
No, it's building on.
Yeah, it's a new feature they had for like regular replication that you can configure a failover master. I think there are also some variables that you can do through variables, if I remember correctly. But yes, you don't need to worry about.
So how many failover masters can I configure? It's only one.
For the regular one is no. I think you can just put a list in there. I don't know if there's a limit.
Because for PXE there will be 3 nodes, right? So can I configure 2 more?
Yes.
Yeah.
Yeah.
For PXE as well?
I never tested with PXE. Yeah, no, I don't think it works with PXE.
It's different protocol.
Yeah.
Or change master to between PXE.
No, it's change master.
No. He means if you have a replica of a.
Okay, between the PXE.
Yeah, good.
Yeah.
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 As long as you have binary
Lost updates.
Yep.
Is there any prevention to someone writing on secondary?
Yes, they're read only. Like super read. They use super read only, and it keeps the variable there. So you can't write it to it, but you can read from there. Like you can configure your MySQL router to read locally on whichever cluster you find best, but writes will only go to the primary of the primary cluster. Yeah. Any more questions? Yep.
So if all the nodes have to be the same version, what's the process like for doing a version upgrade?
So we had a case in Percona support with the upgrade. There is a step-by-step from shell that you can do for upgrading. So you do an upgrade as you upgrade the InnoDB cluster. So it's the same process of upgrading. The asynchronous replication, the versions don't need to match. So I think your primary cluster doesn't need to match the secondary, but they all need to be 8027 or more. Otherwise, the feature doesn't exist. But it's the same as upgrading each InnoDB cluster separately. Yeah.
Well, the single primary moved,
Yes.
that's the refinement. That will reduce the efficiency of the cluster.
So if your cluster, so multi-primary is not always best for performance, because if you have like conflicting writes on multiple nodes, it slows down the entire cluster. So we often recommend writing to only one node, but if your application is built to not write conflicting data to all nodes, and you need to you get some performance gains from that, which are mostly logs, because at the end of the day, all nodes will need to acknowledge all transactions and apply all transactions. So it's like you're not scaling writes really, but you're just distributing your write requests. The logs at least are isolated for each node. So if you have an update comment that logs many rows but changes only a few, and you can run that on 2 different nodes, and they won't lock each other, and if they don't write conflicting data, both will go through, and you gain some performance from it because the logs are isolated. But write throughput doesn't scale with the more nodes you have, even in multi-primary. So, and it's even interesting because the more nodes you add, the slower writes become, because you need acknowledgement from all nodes of your InnoDB cluster. Yeah, so it starts to get, like, you get overhead instead of getting more nodes to write. So to scale write performance, you need like a sharding solution, which we don't have any that we support on Percona at least. There are some builds, like Vitess has a sharding solution, right, for MySQL, but it doesn't scale writes at any rate as well. But yes, you lose that flexibility of choosing. Any more questions? So I think that's it then.
Thank you.
Thank you. Thank you very much. Oh, and we have open spots on Percona, so if you want to work with us, yeah. I'm legally obligated to say that we have. Thank you.